from sets we move to Cartesian product. It is a collection of well-defined objects, and Cartesian product is set of all the ordered pairs from set A to B, and then relation is, it is a subset of the Cartesian product. Relation is a subset of the Cartesian product. Now from relation you are going to the next concept, that is functions. From relation we are moving to functions now. So suppose you just take set A as a set of students who appeared for the exam, and so I just name it as A1, A2, A3, etc. All these are the students. Now these are the marks. This is the marks got by the students. So we'll take it as set B. The marks we take it as M1, M2, like this. All the children appeared for the exam. A1, you will get some mark here. So A1 cannot get one more mark. Is it possible? No. Now A3, sometimes A3 and A1 will have the same mark. Is it possible? It is possible. One child cannot get 2 marks. So A4 will get some mark, and this child also will get some mark. Some marks will be left out. So 0 to the marks are from 0 to 100. Some marks will be without any student. Some 0. Suppose you take 0, nobody would have got 0, isn't it? So maybe 10, nobody would have got 10. So this relation is a function. So a function is nothing but a rule which associates every element. The word every is very important. Every element in the set A is associated with a unique element. So the word unique is also very important. Unique element in B. The one child cannot get 2 marks. Here you can see A1 has got M1, A2 got M2, A3 got M2, A3 did not get M2 and M3. So every element, that is very important, every element in the set A should be associated with a unique element. You understood the concept of function? This is called as a function. So what are the 2 conditions? Every element should be mapped. Nothing should be left out here. Nothing should be left out. That is very important. From the set A, nothing should be left. If something is left out, then it is not a function. So every element in the set A should be associated with a unique element. So one element cannot have 2 images. So this is the set A is called as the domain. A is called the domain, and the set B is called the codomain. The set B is called the codomain, and these elements which are mapped, see which are the elements mapped here? M1, M2, M3 and M6, isn't it? M4, M5 we did not map, nothing, nobody got that marks. So the elements which are mapped, they are called as range. So range is the images. The range is the images, and these elements of the set A are called as the pre-images. This is pre-images we can call, or just the elements, and these are called as the images, these elements. Okay, so that is called pre-image and image. Domain, so you should know these terms. Domain is the set A, the first set. From codomain is the second set is the codomain, and the range is the images, the elements which are mapped. The function is, the definition of function is, every element in the set A should have a unique element in the set B. So when will a relation become a function? A relation becomes a function if each element of the set in the domain, in the domain A, is mapped to exactly one element in the set B. Suppose there is a mirror and you stand in front of the mirror. Is it possible to have no image? If you are standing in front of, you will have. So if there is no image, it is not a function. And suppose if you are standing in front of a mirror and if you get 2 or 3 images, is it possible? How many images of yours will you get? Only one. You are standing in front of the mirror, only one. So there is no image. If there is no image for an element, you are standing here, there is no image, then it is not a function. So every element should have an image, and you cannot have more than one image. What is a one-to-one function? Different elements will have different images. That is called as a one-to-one function. So different elements. So suppose if you have 3 elements here, A, B, C. This is set A. And you have 3 elements here, 1, 2, 3. B. And suppose you have, sometimes you have 4 also, it's okay. Now different elements. Can you see the different elements here? A is different, B is different, C is different. Different elements have different images. Can you see that A is having 1, B is having the image 2, and C has the image 3. So this is a one-to-one function. This is an example for a one-to-one function. So different elements have different images. Then we say it is a one-to-one function. What is onto function? What is an onto? This is a one-to-one function. What is onto? In this case, that is here, you tell me what is the domain in this first one. This is case 1. What is the domain here? What is the domain? ABC, set A, isn't it? ABC. Okay. What is the codomain? What is the codomain? The set B. What is the range? What is the range? It is only the element, the images are called as the range. So this is only 1, 2, 3. Are they equal? The codomain and the range? Are they equal? What is the codomain? The set B. 1, 2, 3, 4. Isn't it? Codomain is the set B. Is set B equal to the range? See, what is the codomain? The set B. What is set B? What is set B? 1, 2, 3, 4. Are they equal? Are they equal? No. So in this case, the codomain is not equal to the range. Codomain is not equal to the range. So this is not, this is called as an into function. What about here? What is the domain here? The domain is the set A. Okay. The codomain is, what is the codomain? Set B. What are the elements of set B? 1, 2, 3. What is the range? The range 1, 2, 3. So are they equal here? Yes. So what is an onto function? If the codomain is equal to the range, nothing should be left. So this is an onto function. This is called as an, this is onto function. This is also one-to-one anyway. It's one-to-one also onto. Here this is one-to-one, but this is into. Understood the difference? If the codomain is equal to the range, we call it as an onto function. So onto is when the codomain is equal to the range. What is many to one? Many elements are mapped. Is it onto or into? What is a codomain? Codomain is ABC and the range is A. So this is an into function. This is many to one into function. Constant function, then identity function. What is the meaning of constant? The word constant means, what's constant means no change, it won't change. Suppose if I take an equation 5x plus 3, this 3 is a constant. It is not going to change. This x is a variable. X will change when 3 is a constant. There is no change. So suppose all the elements in the set A, see set A elements you have A, B, C. Now everything goes to a particular constant. Everything is mapped to a constant. F of A is K. Everything is mapped to a particular constant. Then we say it is a constant function. This is also a constant function. Everything is mapped to A. Can you see that? So it is called as a constant function. F of x, the definition of a constant function is f of x is equal to a constant. There is no x here. Now what is an identity function? F of x is equal to x itself. So if I put f of 1, it gives identity, means it gives the same thing. Identity, constant means it will go to a particular number. Constant, it will not change. All the elements the set A are going to that particular number. It is called as a constant function. Identity means everything will go to itself. That is f of 1 go to 1. F of 2 will go to 2. So this is called identity. F of x is equal to x itself. A will go to A itself. B will be mapped to B. C B will map to C. So this is an identity matrix. So identity, the definition is f of x is equal to x itself. That is